The pilot of an airplane flies at a constant speed of 180 kilometers per hour and a bearing of north 30 degrees east. There is a 35 kilometer per hour crosswind blowing at south 50 degrees west. What are the plane's actual speed and direction? Okay, so this is a vector addition problem, but we want to start with each individual vector and then kind of put the information together. So let's draw the diagram for the airplane. So we start with the line that's north, and then we take a 30 degrees angle towards the east. So it's kind of like this vector right here. Now the angle is between the north and the vector. Also the length of the vector is 180 because the length represents the speed. So we need the inside angle, which would be 60. So we draw a triangle inside here, and we want to find the x and the y component in this picture. Okay, so to find x, since x is the adjacent to the angle, and we have the hypotenuse, we're going to use cosine. So cosine of 60 equals x over 180. So adjacent over hypotenuse. So solve for x. So we have 180 cosine of 60 equals x. So x is approximately 90. Okay, so the y component. Similarly, we use some trig, and y is the opposite. So we use sine. Sine of 60 equals y over 180. So we have 180 sine of 60 equals y. So as we plug this into the calculator, we get that y is about 155.9. Okay, so if we wanted to write this in component form, so we have the x component, which is 90, the y component 155.9. Okay, so now we do the same thing for the wind. So if I draw the axis, so this time the wind is blowing south 50 degrees west. So start with south. That's the arrow down, and then you go 50 degrees towards the west. So that's that. So the 50-degree angle is right here. The wind speed is 35, so that's the length of the vector. So again, draw your triangle. So again, we want to find the x and the y component. We need the inside angle, so the inside angle would be 40 degrees. Okay, and so the procedure is the same, cosine for x, sine for y. So let's do this. Cosine of 40 equals x over 35. So 35 cosine of 40 equals x. So when we plug this into the calculator, we get 26.8. So the sine of 40 equals y over 35. Okay, again, cross multiply. So we have 35 sine of 40 equals y. So y equals 22.5. Now for our second vector, and we have to pay attention to the signs. Our first vector was entirely in the first quadrant. Now the wind speed is pointing towards the south and the west. So third quadrant, both the x and y components are negative. So negative 26.8, and then negative 22.5. Okay, so we have our two components there. So now we have to find the resultant vector. So we took the two vectors apart, but really we want to see what effect does the wind have on the airplane. So we need to add the two vectors together. So the resultant, so we add them. So we have 90 plus negative 26.8. And then at the y component, 155.9 plus negative 22.5. So when we add those two together, the result is 63.2 and 133.4. So we're still in the first quadrant. The wind has knocked our airplane out of the first quadrant, but we're just in a different place now. So let's draw the picture that goes with this. So if you think about our original problem, so we have this airplane that's kind of flying along this way, then we have a wind that's blowing this direction, so we have a resultant vector kind of like that. We don't know exactly what the angle is, but we just have the x and y component. So if you think about this, it's this and this side. So 63.2 and 133.4. So we need to find two things. We need to find the speed, which is represented by the magnitude of the vector, and we need to find the direction, which is the angle formed. So let's do the speed first. Now the speed, we can just use Pythagorean theorem. We have 63.2 squared plus 133.4 squared, and we just need to take the square root of that. So when we plug this into the calculator, this comes out to 147.6 kilometers per hour. So that's the speed. We still have to find the direction. So we have to find this inside angle here. Okay, so since we have the opposite and we have the adjacent, we're going to use tangent. Now there are other ways of finding it. Since we have found the speed, that's the hypotenuse of this triangle, but let's use tangent. Tangent of A equals opposite, which is 133.4 over 63.2. So A, we need to use the inverse tangent because we need to get to that angle. Now this comes out to approximately 64.7. Now that's the angle. We still need to attach some direction to that in terms of north, south, west, or east. So since we are starting with the side that points towards east, and then we're going 64.7 degrees up towards the north, we put east. I'm going to round it to the whole number, 65 degrees north.